Hello, everyone. Welcome back from the brief break that we just had. ZJ and I were briefly chatting off stage before the presentation. I think it's going to be super interesting for everyone, especially involved on the plant floor and manufacturing side. We are talking about LLMs, we're talking about MCP. For those who are unfamiliar with both of those in this context, I think it's going to be very interesting. It is certainly topic of mind for many of my conversations. So I'm looking forward to hearing ZJ explain a specific project. ZJ, without any further delay, give us an intro and obviously dive into your talk.
Yeah, sure. I am gonna delay though because I just want a big shout out to Indira who set up the whole conference and did an amazing job so far. We had over 1,000 participants so far today, nearly 2,000 registrations. So like if this was in person, I would say everyone clap, but there is chat, you can thank her there. Highly appreciate it. And then indeed, I'll go back to the talk. And it's about Node-RED, LLMs, and MCP, because that is obviously the hot topic, but also it's a bit about the journey I took myself on, like first kind of being a skeptic on this whole LLM wave, and then further on realizing, especially with MCP hitting the stage, that this is actually something that makes a lot of sense. And also for where Node-RED really shines, connecting the physical to the digital and back again. So who am I to talk about this? I am the CEO at FlowFuse. I mostly take care of the business side, and then Nick shines at the technical side. So he is the CTO of FlowFuse as well as the maintainer of Node-RED. FlowFuse is the biggest corporate sponsor of Node-RED, both financials and development. And we really want to bring Node-RED to an open source to Fuse. So that's where the Fuse comes from, the digital realm and the machines and the shop floor, the IoT use cases as well. My background is in IT, and so this whole manufacturing thing was new for me. I had to learn what OPC UA was and Modbus, and it was quite a journey. Without further ado, I'll just start where my journey really started. And I saw this chart from one of our customers a while back, and we were discussing how they were using our product and where the Node-RED applied and where they were successful with it. And this was one of the charts where this is obviously a problem, but it was cool to detect the problem, and we were kind of nerding out about how this technology got information from 5 machines and got information from data and made it actionable. So if you're parsing this still, the top row are 2 charts, and these are kilowatts hours usage per machine. And so the left-hand side on the top row is machine 5 had most energy usage by far. And this could mean it just did more parts, and so the engineer, cleverer than I was, also divided by
ZJ,
the...
sorry to interrupt. I think you need to reshare the slides, please.
Okay.
I think once we entered the main stage, slides are...
That's all right. Do you see slides
Excellent.
now?
Yes, sir.
All
Thank you.
right, cool. So now you got more time to parse the charts, and I'll walk you through it. So the first row was kilowatt hour usage of machines. There are 5 machines in this case, and 5 was using more. And so the engineer I was talking to was clever enough to divide it over the parts produced. And apparently machine 5 is way less efficient than all the other machines. And then below is kilovolt amps, kind of to further investigate. So what happened in this whole story is we had data capture from multiple machines, transport them, combine them, visualize them. This was the Node-RED success case, and I was really pleased with, first of all, they spotted the problem, and also as a company and as an open source product, that this is possible with the product, and there's real world value here. And so what I did, as any startup CEO would do, is you ask for permission to share the screenshot. I shared the screenshot and basically made a LinkedIn post to talk about how low code is gonna basically take my old job as IT software developer away. Because what really happened is, like, in a couple of hours, someone integrated OPC UA and other protocols, which IT, if you ask them, like, please implement this, will take them weeks and weeks. It would be error prone, hard to maintain, and you have this one ITer who is great at integrating one machine and has all the knowledge, therefore it's called tribal knowledge, and to extract it out of them, quite the challenge. And then you got Node-RED, and the future of programming really is, we got a problem, let's drag and drop a solution together. From top down, on like a problem level, you reason about, hey, what do I really need to understand what's going on? Where is the data coming from, and where is the data going to? And from there on out, we built very fast solutions where a very broad spectrum of engineers can actually be applied to. And what's even cooler, I think everyone in their work has a couple of hunches where I think I can optimize something about the business if I only can build this dashboard, and if I can only get this data. And now with open source, this is possible. Again, great success story for the business. This chart remained on my desktop, as many other charts, and recently I looked at it again, and I started to wonder, like, was this really a success? Because ultimately what happened is, we just pointed at the problem and then was hands off, and like, so now what? And my background is in IT, so I knew full well, like, I wouldn't be able to offer anything of value for this other engineer, or like a couple of hints. So, like, how would this actually play out in real life, right? And what I noticed also on, like, Node-RED flows, you have data flowing from left to right. And for everyone you talk to, either the left-hand side feels very comfortable and knowledgeable, and this is the area we'd like to work in, or the right-hand side. For some reason, there is always a crossover section where it's like, oh, now I know less of this problem space. So for me, as soon as the data goes into IT, like a Snowflake, like a PostgreSDB, or a historian, I feel right at home. I know exactly what to do. And then the other side, like, the data comes from the machine, from Modbus or OPC UA. It's like, okay, this is not so great. Maybe even for me, even worse, like, the data needs to be extracted from physical devices still, from analog with like voltage reading. I mean, I would have been lost. And so somewhere when the data flows from left to right, we cross from comfortable to uncomfortable, or from uncomfortable to comfortable. And that got me thinking on, like, there's always a challenge in the middle, and it would be much better if we could do it the other way around. So if the question is, like, what was the energy consumption for machine 4, why couldn't we be asking exactly that? And that's what got me thinking, because this case, I wouldn't be able to solve it. And it would be great to just shortcut either the learning or make people less uncomfortable in one of those two sides of the integration puzzle. So what if we go from low-level machine or low-level IT questions to high-level, what changed in the energy consumption for machine 4, and can you please tell me when? Just to answer this question, you need to connect the machines. So there are some prerequisites, but recently, especially with the advance of LLM and MCP, these questions become answerable by just typing plain text, not code, but plain text. And, well, going downstairs for a coffee, or to the office to the coffee, and then when you're back from the coffee machine, generally you'll have your answer. And so to extend this beyond just this one case, I recently bought a PLC, and I had to get some data from it. These days, obviously, you'll use an LLM to just get yourself in the right headspace and get yourself in the space where you get more answers, or at least pointers toward the answers, and you're still an engineer. You still have to resolve the real problems yourself. Cool. And then there's a poll and quiz right now, so do answer that while I remain talking. I'll go through the components a bit of like the sum I put at the bottom of the previous slide. The LLM, I think, is very well known by now. These are the text prompts. ChatGPT is the most familiar one, I think, and then you have Claude, Gemini, etc. They basically work by predicting what the next word is going to be in the sentence. It's incredible technology that apparently gets a lot of right answers in querying, well, after humans are querying this with natural language, which is quite different from before, where humans were querying computers in computer language. The code that you wrote, even if it's high-level code like JavaScript, first had to be interpreted to machine code, then to instructions for the machine. And now we get this liberation basically from this whole layer if we can utilize LLMs. However, and especially when LLMs came to the scene, I was quite skeptic because like, this is all in the cloud, it's fairly slow, data, especially event-based data, is not being handled by LLMs at all. Their prediction model is trained at one point in time and then executed for the next couple of months. And then it's retrained with new knowledge and then redeployed at one point in time for the next time frame. This fundamental limitation still remains with LLMs. That's not fixed. And it's still mostly in the cloud. These days, there are models you can run locally, but you need a pretty good machine to actually do this and also get a latency on your answers that you'd want. So on towards the next innovation really over I would say the last year that made LLMs much more parsable and adaptable. And these would be MCPs, or Model Context Protocol. The problem was, like, if you have questions about data that is available to you now, or only data that's available to you and not someone else, the model can't be trained on it. So there is context that you'd want to load into the model and query that context as well. So initially these were emails, but like in our case, this could be your Roomba at home, or maybe your energy usage of your home. If you're into home automation, the production for solar could be very interesting, as well as some context to load on when your Roomba is going out. But for the industrial scale, the same could be applied for example, energy costs right now, or Fluidly earlier today could build an MCP around foreign exchange rates. So it's quite a broad protocol that can adapt resources. Resources are read-only, or tools, and tools you can do something with, and make them available for the LLM to use. However, this is a fairly straightforward protocol. It's unaware of logic. It's a small interface, and it does one thing and one thing only, really. It reads the state or performs an action. In many ways, it's a sort of wrapper around a REST API where, you ask for an action to be taken, you get a response from the server, and that's about it. There's no logic in there, or it's not a brain. It's really an adapter. And then so lastly, actually, this was one of the examples. So with FlowFuse, we published the MCP nodes. So on the left-hand side, I hope my cursor is visible as well. This is what we call a tool. So we connected a stack light to an MCP tool. So we said there's an action to be taken with the stack light. You can turn it green, orange, or red. And then message comes in. the tool sends the payload to this IP on the right-hand side, which is an S7 way from Siemens to put the stack light in a certain color. And meanwhile, we also send the MCP response back to the LLM. So this means that there is a way to take your current logic and your current adapters for your machine floor, which you've now integrated with IT through Node-RED, and also make them LLM and AI ready.
Question for you, ZJ, on the MCP front, right? So
Yeah.
our industry, which is industrial automation and manufacturing, is still fairly closed down. So I'm curious whether you see a world where some of those proprietary hardware vendors will open up MCPs towards their hardware, or it's going to be on the community to some extent to build out some of those connectors, and whether or not those will be, more open source and accessible, because ultimately from the closed off hardware vendor standpoint, you're now pulling this data and are able to make decisions in a third party application versus, using their licenses and their tools.
Yeah. So that's exactly what Node-RED is actually already doing, right? The MCP node is new, but there are already thousands of connectors to proprietary protocols, but also to more open ones like the S7. That's this example. So it's like almost every connection with Node-RED, highly versatile. And if you know the protocol, you can still use it, and you can adapt your infrastructure, both OT and IT, to the MCP protocol. It's, yeah, like extracting data with Node-RED or pushing data back in with Node-RED now. There's no real thing that most manufacturers will be doing about it or can be doing about it. If the interface is known, if you know how to talk to this machine, or if you know how to listen to this machine, you can adapt it to the MCP world.
Gotcha. Thank you.
So yeah, also here, like this is a very small example, but if you already have, for example, an API to I don't know, ask for replacement parts at a station in manufacturing, or query a database that has certain knowledge, the adaptation is really a link node in Node-RED and just one group in a nice color away. And from there on out, you're off to the races. So now lastly, obviously you need Node-RED. Also well, this slide would have been a better answer to your question, Vlad, but here we go. There is still this need for one integration layer that connects old to new, so the machine to MCP, but also to connect whatever comes after. For example, MCP or MCP2 is released. You'll need one shell to actually do the dirty work, as being phrased in the middle of the slide. And this is where Node-RED really shines. The downside compared to like an LLM, the logic is explicit. You still need to drag and drop the solution, and you need a human to wire this all together. Sure, FlowFuse has released the AI assistant for to do most of, like, for example, the function nodes implementations. I'm sorry. There's also the way to like explain what this flow is doing, and we're working on expanding subflows, etc. So that gets easier with LLMs as well. But on the runtime, Node-RED is still the bread and butter. Data flows from left to right, from node to node, and that doesn't materially change with the advent of AI. However, we do get now in a situation where we can combine them in a sequence. So you got the LLM. This is your human text interface to output, regardless of what the question is. And then you got the MCP that can take actions or read the data from the physical environments. And then Node-RED to make those to, well, interact well together. And so, yeah, the whole chain, you got the three components that make you able to, one of the earlier slides had an example, like fill the pump, or in the middle as well. So you make an MCP tool, something that can do something, create an action, and then you make resources, for example, for if this is a flow meter, what is the flow now? And so when do we expect this tank of water, for example, to be open, to be full? And then with that, you can start to reason with an LLM and a human in the loop to get solutions together, where both the left and the right-hand side of your flows traditionally, where one of those were uncertain, have more pointers and more help on what is to be expected on the side you are most uncomfortable with. All right. And so then one thing to bring it all together. So we're working now on making MCP sort of service discovery, because if you create an MCP server, so that would be a tool, a resource, or prompt, there's no service discovery, meaning if you allow a stack light to be changing colors, you still need to inform the LLM that these options are available. So that's where we can bring it all together in an interface like FlowFuse, or you can do this in VS Code or other tools as well. And at that stage, these services can be available, discoverable by both the human as well as the LLM, to be utilized to its full extent. And with that, I foresee that the future is more text-driven playbooks. So the question becomes, how do we optimize a certain procedure in the factory? And the playbook will be played out by one of your colleagues. So in the example of the screenshot, for example, Sarah Johnson. And then the rest of the company can actually read and understand how she did this, and from there on out start to create excellence, operational excellence, that is, for the company, with humans and human text as input and not code, and then furthering actually like the Node-RED goal of having more people being able to optimize their surroundings. All right, so that was like the 10K overview of MCP and LLMs and Node-RED. There is an exhibitors area, so if you want to chat some more on how to implement this, I'll be there. And otherwise, I'll open the floor for questions, Vlad.
Yes. A couple of questions for you, ZJ. So, one, where are you seeing the most bottlenecks for these types of applications, right? Is it getting the data? Is it processing the data? Is it the hallucinations that everyone's talking about? Is it educating, operators and decision makers to use AI, and obviously some of the implementation questions as well?
Well, yeah, all of the above.
Hmm.
So like the question you asked earlier, like, can we integrate every machine?
Sure.
I've not seen a machine we can't integrate with Node-RED, and so by extent with MCP, and make it AI ready. If you are in the audience and you think like, I've got a machine for you, there's my email. I'd love the challenge. But there is still the case of proprietary protocols where some things might be underutilized or not quite optimal. So there's a bit of like, how do you interface with your surroundings? Then obviously humans are always, well, it's challenging indeed, because an AI, when they're wrong, they're as confident as when they're right. And this is one of the challenges why also the way we propose this solution here, it would be chat with a human in the loop. I don't think in the next, well, let's say 5 years, there will be complete runbooks which LLMs will just execute. Because there's the other thing with LLMs, it's predictive. And in certain ways it's random. So right now, if you input the same things and the context slightly changes because the value is different, or there's something, you don't know what the output is. So you will always need a human, and the human can use this as a partner, as a thought partner, to bounce ideas off. But like the next 5 years, like I said before, this is not a playbook thing. This is not a logic to be executed. It is well, making the uncomfortable part of your flow more comfortable and getting you across the hurdle of implementing.
And there were a lot of comments on that front, right? As you mentioned, the human in the loop, and someone even made a comment saying passing such control to a non-deterministic system is extremely scary, and it definitely resonates, right? But I think there's still a thought, where do we put those guardrails, right? So you can take a simpler example where maybe you're not necessarily influencing OE by changing entire code of, let's say, your machine, but maybe you're adjusting some small PID type of set points, right? Which is maybe more machine learning than anything else, but still, maybe there is an opportunity to put guardrails where you can automate some of those more manual processes. So curious your thoughts. Maybe there is some things that you would let AI be completely handling.
Yeah, so right. Well, if this was just code, then almost all code you can revert and just rerun again and then just revert to a certain. As soon as your consequences are physical, much harder. So like you boil an egg and now like you can't get it back into its shell. Like that's just the way that physical works. And so human in the loop will always be a requirement as soon as the stakes become higher. So right now, even if you look at like code writing with LLMs and MCP, there's still humans in the loop until you voluntarily give away this control. I those controls will some of those you'll just never be able to give away to an LLM and just wait until it executes whatever it's going to do. And so the phases it's going to go through for everything that's reversible. So you're writing a blog post, all those things. I expect a lot of LLMs to be applied very swiftly in that area. Um,
Mhm.
yeah, exactly. Like rerouting production towards another line, quite consequential, but also, yeah, probably something you want to do. If it's safety related, you probably want to have it 100% deterministic, maybe 100% mechanical even, and not have anything IT involved at all. So there's always consequences and there's always a trade-off to be made in the lower the consequences, the easier you can give away control.
Mhm.
But this is also with automation, right? Like industrial automation as a business case is, well, since the advent of compute already tackling this problem. I don't think the industry is in a tough spot right now to think about this because they have what 5 decades of experience already thinking about this.
Absolutely. The other question, and I guess expanding on that just a little bit, right? Everyone's looking for different use cases to sort of get their feet wet in applications that maybe are not as process critical. So obviously the usual conversations around predictive maintenance, or maybe even pulling some of the financials to better understand the state of your line, start coming to mind. Are you, I guess, able to talk to any type of case studies, or have you had conversations on fronts where, again, it's less critical, therefore AI can play a much more significant role in offloading some of those business cases that in the past were, again, done through an ERP or an MES, but now can be handled by LLMs and MCPs?
Yeah, so the cases we are seeing are strictly digital at this stage. That goes again back to like the consequences and how fast can you roll back your actions, or is there even a playground to prove this technology in? Um, so there's no real use case right now where FlowFuse is able to say stop this production line because, for example, the energy spike is high. Um, and I don't foresee that happening in the next year. As with everything, these cases will iterate in terms of impact. And so right now it's triggering a stack light or notifying someone that there is something going on at machine 5. We just don't know what it is. And from there on out, after a while, we can get more context and thus more influence. And so also the implementations of what FlowFuse will do with our customers are going to iterate there. So at this stage, we're mostly like the true impact would be, can you improve my overall efficiency with 2% point? And then you hit enter and you just wait and see. An hour later, report comes back and then you say, I accept this conclusion. That would be the ideal state. Before we're there, I mean, a decade maybe. It's just so much data, so complex, so many assumptions that you need to make as a human. I don't think we're anywhere close. But so turning a stack light orange that might signal an engineer to get you to the right location, and thus like less downtime. Those things are much like around the corner, really.
Awesome, ZJ. I really appreciate it. I know there's a lot more thoughts in the chat that are coming in. So if anyone wants to connect with either ZJ or somebody from FlowFuse, you can do that from the lobby by clicking the Expo button and then joining the booth. And we will see you in just a minute in the next presentation, which is going to be around the semiconductor industry. Thank you so much, everyone. Thank you, ZJ.
Thanks,
Appreciate
Flo.
it. Yep.
Bye, everyone.